Welcome everybody. I hope you can hear me fine. Seeing is less important, but I hope you can hear me. So welcome to this laser event, as we call it, hosted by Tigera. And the topic of today is Egress access control for Kubernetes, which is a particular topic in the context of access control related to Kubernetes and the external world. Let me introduce you also to Jane. Jane is my colleague based in the UK and is responsible for EMEA. And myself, I'm Philip. I'm a solution architect based in Brussels. Okay. So myself, I'm a solution architect at Tigera since a couple of months already. My previous experience related to Kubernetes and networking is mostly at F5 and AVI networks, which are networking and load balancing related topics, as well as with a few other security companies where I was involved with securing Kubernetes. It's also one of my hobbies, hacking Kubernetes, and that's why I'm also participating in something which is called Brucon, which is a hacking conference in Belgium, where we discuss these topics. If you want to check me out, feel free. If not, follow my adventures on Twitter, where I typically post some tutorials or hacking documents or something like that. So feel free to check it out. So back to Calico Tigera. So Project Calico, as you probably know, is a community-driven project that focuses on open source networking, typically referred to as the Calico CNI, which basically makes sure that you can communicate in between your Kubernetes pods and hosts and so on, as well as a network security solution, allowing us to build network security policies, so access control in between these resources. Calico itself is community-driven. The company behind it is Tigera. So Tigera is helping the community to build this and manage this project. Before I forget, there are a few other events coming up. We host a series of events typically related to Kubernetes or the open source Calico. A few of them also relate to the enterprise version of Calico. There are a few coming up, mostly around multi-cluster management and federation. So if you're interested, check it out. If not, go to the link shown here and you can sign up to, I think, end of September. We will be hosting about 2 to 3 events a week. So feel free to check it out and let's learn some stuff about Calico. As I said, Calico is community driven. So there's of course a website, there's some Twitter, but the most important thing I wanted to bring up is please go to the Slack channel of Project Calico. There are a lot of members that can help you. There are people from Tigera on it, a lot of volunteers that help out. So there are a lot of people on that Slack channel. So the easiest way and probably the fastest way to get your questions answered or reproduced is through that Slack channel. So I encourage you again to do that. It's a very learningful and useful experience. So Calico itself, as I mentioned, is a networking solution. The cool thing about Calico is that it is actually being used in the largest deployments around the world, talking about hundreds up to thousands nodes in clusters. So it's a very scalable and feature-rich networking solution. And it's not only apply to containers or Kubernetes, but it's also very useful if you want to link your container environment to VM, for example, where you host some databases. As we will see right away, it's not as easy as it sounds to connect containers to VMs, because that's mostly the topic of the Egress today. But with the Calico solution, you can fairly easily do that. Today will be a mix about Kubernetes, Calico open source, and Calico Enterprise, just to showcase and show and explain the differences. I will point out when we talk about one or the other. So if you want to play around with Calico or use it, feel free. You can find it mostly everywhere. So all the 4 big cloud providers to support Calico networking security policies, which is mainly the topic of today. But also some have by default or have optional support for Calico networking. That's for the cloud providers. Of course, you can use Calico in a series of on-premise solutions, where it's plain vanilla Kubernetes or Docker EE or OpenShift, Rancher, VMware for free. Most of these solutions do support the Calico networking layer as well as the network security policy layer. Okay, we'll be using today a few machines on AWS. I have an OpenShift cluster up and running. I have a Firewall up and running. So we'll switch around a few of these environments today. So I always have to start out with a small recap about the networking, because that's at the beginning why we need all the stuff we're going to discuss. So that means that networking in Kubernetes is quite often described as something which is not part of Kubernetes. That's why you have a plugin, a network plugin. And one of the guidelines that Kubernetes is imposing is that all the pods inside of a Kubernetes cluster can talk to each other. That means that they need an IP address, a unique IP address within the cluster, but also without being address translated. That means that in a Kubernetes cluster, every pod can talk to every pod, and every pod can actually see the source IP address of the pod that initiates connections. So in a microservices architecture, that means that every pod should be able to see the source IP of the pod originating the connection. Now, that's all pretty cool. And we say, okay, IP addresses, that means that we can apply access lists. If life that was that simple, pods inside of Kubernetes have a very dynamic, are very dynamic of a nature, because IP addresses are essentially assigned according to an IP address scheme, but it looks like it is basically random, or at least it's hard to predict which IP address is actually going to be assigned to a pod. On top, pods inside of Kubernetes cluster are typically non-routable outside of the cluster. That means that this is very often implemented by a private IP range. And so outside of your cluster, it's very hard to actually address these pods. Calico can do it, but at the end of the day, it's still probably a non-routable IP address. We'll discuss this in further later. So as I said, the thing that is actually controlling all this networking or cluster networking is called the CNI. So for Calico, this is the Calico CNI plugin that you install when you install Kubernetes or OpenShift or something. So it's Calico that makes sure that there is an IP address assigned to every pod, which is the address management. And Calico also makes sure that in between your clusters, these pods can actually reach each other. That also means that Calico needs to make sure that in some cases it needs to create an overlay network. That can be IP and IP or VXLAN, which is pretty common. But the cool thing is Calico also supports what is called a non-encapsulated mode. That means that it doesn't use any tunneling, but it just makes sure through means of BGP, which is handled automatically by Calico, so it can actually route pods from one node to another. And this means that you have visibility of the IP addresses of the pods, let's say, in the underlying network. It looks a bit complicated, all these modes, but there are indeed some advantages, meaning that, for example, from a intrusion prevention systems can actually see the IP address of pods, routing can see it, firewalls can see it, which remediates quite some issues. We'll talk about that later. So, as I said, there is a dynamic nature in the way pods have IP addresses. So we need to come up with something new, basically identify pods. And the cool thing in Kubernetes is that you can actually label pods. The moment you can actually label a pod means that you can actually say, okay, these pods have a label come, for example, DMZ. And you can create afterwards policies that said, okay, everything which has the label DMZ is allowed to connect to, for example, the middleware, or everything which is labeled allow internet can actually access the internet. The moment you add or remove a label, let's say the access lists which are behind it are dynamically updated. So that's a cool way to do that. And as I mentioned, we can do that for Kubernetes and pods, which we know is actually very easy to use labels, but exactly the same is possible for VMs if you install Calico on top of it. So a deployment example here, I use this slide quite a lot, but in brief, basically when you deploy, for example, an Nginx container in this case, the deployment specifies how many replicas you should have. So at that point, we will actually spin up, in this case, 3 versions of the Nginx image. As I said, depending on which node, they will get a different IP address. The block in which this is assigned is decided by Calico. So that means that these pods come up and the IP address is decided by Calico. As I said, it's dynamic in nature. That also means that if we, for example, scale up this deployment, we'll probably spin up some pods on one or the other node, which is actually decided by the scheduler in Kubernetes. And depending on which node, Calico will assign, of course, an IP address. Of course, things can go wrong. So imagine that, for example, pod 4 crashes. Well, Kubernetes will detect that this pod has been gone, and it will automatically, that's the declarative part of it, make sure it lives up to its promises. And the promise in this case was 5. So it will automatically spin up a 6 pod where we have resources available. Just to point out the dynamic nature of Kubernetes and the fact that the IP addresses that the pods are using are actually, from a user experience, looking pretty randomly. So how to do that? As you can see, every pod will be assigned labels. In this case, the label will be app Nginx. That means that every pod in this deployment will at least have a label called app Nginx, as well it also will have technically a label identifying the Nginx deployment, but keep that aside for today. So based on that, we can actually go and build rules. So network policies as such, and I always find myself trying to figure it out myself, and sometimes I have to go back to what I actually try to describe here. Network policies essentially is a way to say what is allowed to come into a pod and what is allowed to get out of a pod. Depending on where you come from, I've been playing with proxies and firewalls for practically half of my life. And I always looked at it from a gateway's perspective, as a router perspective, where you could actually say, I allow traffic originating from here going to there. And I'm sitting in the middle playing police officer. When you talk about network policies inside of Kubernetes or pods, or actually also in clouds, for example, security groups in AWS, you have to look at it from a different perspective. So to quickly explain this, first of all, network policies are applied on a namespace. That means that the policy which is following down here is actually only applicable inside of a specific namespace. That means that for every network security policy, for Kubernetes at least, you have to apply the policy inside of the namespace. To make it a little bit more complex, these policies are only applied on a series of pods. And as you can see, in this case, the pod selector is match labels role equals database. That means that the security policy that we're building will only be applied on the pods with a specific label, in this case, role DB. That means that in this scenario, the only pods that really will have a security policy are the pods DB. The role front-end, role helpers won't have any policies attached. So be careful with this, because this means that it's not because you apply this, role front-end cannot do anything else, for example, like connecting to the internet. Then we have the concept of ingress and egress. So ingress needs to be interpreted as traffic or connections flowing into the pod. It's stateful, but it means that connections from outside into the pod are allowed or blocked, depending if you're using Kubernetes or Calico. And the egress, of course, basically means what is allowed to get out of the pod. I reiterate, this policy is only applied on the pods with a label role DB. So there is nothing applied on role frontend. There is nothing applied on role helper. If you have like a fourth pod sitting around and you would label it role DB, well, it will automatically be added to this policy, and automatically the policies will be applied. Changing or applying policies is essentially in real time. That means at the moment you apply this policy in Kubernetes, it will be effective immediately. Okay. Now, we'll jump to egress in the next slide, but as I already pointed out, you have egress and ingress, of course. So this is actually an example of an ingress policy, so totally out of scope for this presentation, but just for the completeness. So it's applied to role DB in this case, and it actually says, I only accept traffic from role frontend. Means that traffic flowing into these pods, are actually allowed on port 6379, as long as the connection is originating from pods with this label. So this looks easy, and that's what we mostly use. But let's look at egress. Egress sometimes is a little bit more difficult to understand. So egress policies are applied, as I mentioned, to pods which match these pod selectors. So in this case, we use red. That means that the pods that have this label, in this case, will have an egress policy, and the egress policy is, just as an example, saying that it can only connect to this site. It could also be something like you can connect to the pods with role DB. Yeah, so you have support for IP blocks, but you can also use namespace selectors and pod selectors and so on and so forth when you define the egress policy. So it's the outgoing connections that will be controlled. Please note, if you would only apply this policy, you can still connect to pod with the labels color red. So nothing is preventing that. You can build policies, as I showed you in this first example, that have ingress and egress blocks in the same policy. Okay, so in this case, once you apply this, the only thing that will happen is that pods with a label red are able to connect to this network range, which is a little bit tricky if you think about it, because pods, the way they communicate is, as I already said a few times, by IP address. But since IP addresses are dynamic, you have the concept of services inside of Kubernetes, which is an abstraction to say, I connect to this service, and then Kubernetes will make sure that you are directed to one or the other pod belonging to that service. But to basically resolve the IP address, or to find actually the IP address of a service, you use DNS. So a very good starting point is, if you want to play around with policies, and for sure egress policies, is not to blankly say, I block everything, but to make sure that you have a decent default deny policy. So if you would copy paste this network policy and apply it, as you can see, it's linked to a specific namespace. It will match all the pods inside of the namespace. It will be applied in egress and ingress and egress direction with no things allowed. So copy pasting this would actually result in blocking all incoming and all outgoing traffic. That's a very secure way of doing it. The problem is that you will actually block out DNS. So that means that the moment you want to allow communication, we have to go and open holes in our policies. Remember that Kubernetes policies, since we're still talking about it, don't have a block option. They can only allow things. So in this case, it's actually allowing nothing, but that's also a way to allow things. So if we need to allow DNS, as you will see in the examples, we need to create an explicit exception for DNS on port 53. So besides Kubernetes policies and the idea of having a default deny policy as a starting point is pretty cool. But as we already probably pointed out in previous sessions, Kubernetes policies are pretty cool, but they lack a few features like blocking or allowing or logging, for example. And one of the other ones is essentially what is called Calico network sets. Calico network sets is actually a Calico open source feature that allow us to actually build a set of network addresses, as the name suggests. Just think about it as a list of IP addresses that you give a label. For example, this is a network set. These are the IP addresses that actually belong to that set. And we actually gave it a label role DB. That means that once you create these network sets and afterwards you create a policy instead of managing these network sets, yeah, you can just reference in your policy, for example, role DB. Yeah. This is the basis of how you can manage a list, how you can do threat prevention, and essentially towards the end of the presentation, also how actually external firewall integration works. Calico has two types of network sets. One is a network set resource, which is namespace bound. This is the example. But Calico also supports not only namespace network policies, as you know, it also supports global policies. And global policies are actually policies which are not bound to a namespace. So as well as there is a namespace network set, there's also a global network set, which is actually more or less the same, except the kind of the resource, which is different. And that can be used in global policies, which is cool. And I'll show you an example. Calico Enterprise also allows you to actually store fully qualified domain names inside of a network set. So you can do something like star.google.com, and then Calico Enterprise can actually limit or allow access to, for example, only google.com. So this is the two things linked together. So in this left, we actually create a network set. But there is a mistake in the formatting here. Where we call, for example, this list and we label it as API. This is a Calico network security policy. So it's a namespace security policy. So you can see policies in Calico have an order. And in this case, this is actually what I will be using in the demo. We actually have all the pods that are allowed internet access. So the pods which have this label are selected, and we will actually deny them access to everything which has the role equals API. So automatically, we don't have to touch this policy as long as we update this network set. Well, everything we add to it will automatically be denied in this case. So that's an easy way to actually control access to IP addresses, APIs, or well-known IP addresses. Okay. So all these examples actually, and there are a few others you can find on docs.project.calico or docs.tigera.io, are actually solutions that limit outgoing pod access to the external world or to other pods. Yeah. The problem is when these pods, for example, like in this case, will connect to the internet, what is actually the source IP address you will see outside of your clusters. So let me use this drawing for this. So that means that the moment your pods are talking to each other, one of the design guides of Kubernetes says that every pod should be able to see every pod, all cool. We can build policies on it to make sure that the right pods talk to the right pods. But what if these pods are actually connecting to, for example, the internet? Well, that's more complicated to control because we need to actually investigate what the routers or the firewalls are actually seeing. And as I already mentioned, a lot of solutions, not only Calico, but there are others outside Calico also, of course, they typically use a kind of encapsulation technique. Calico can use IP and IP or VXLAN. which actually means that all the traffic going from one pod to another pod, when you would actually look at the network layer just in front of the nodes, what do you actually see? In this case, you would see some tunnel traffic in between the pods. But the moment, for example, pod 1 would actually access the internet or a VM somewhere on the network, what will actually happen is that the pod IP address will be address translated, typically referred to as a SNAT, source address translation, behind the node IP it is actually leaving on. That means if pod 1 would connect to Google, the firewall here would actually see the IP address of node 1 and not of pod 1. But if pod 1 would crash and would come up on node 2, for example, and node 2 would connect to Google, well, it would do exactly the same. It would be going out and IP tables will intercept it and actually do a source net to the IP address of node 2. So bottom line is that the firewall in this scenario is actually only seeing node 1, node 2, and node 3. Although we can implement an access policy on the Kubernetes cluster saying that only Nginx is allowed to connect to the internet, the problem is that you cannot or hardly enforce it on the firewall, because the firewall will only see the IP addresses of node 1, 2, and 3. Now, you might say, yeah, it's not a problem because it's already enforced on node 1 and node 2. But imagine that we're using Kubernetes policies. And as I mentioned, there are namespace. So if somebody creates a namespace 1 and says, okay, you're not allowed, or namespace 1 is allowed to connect to the internet, and somebody else creates namespace 2 and doesn't implement any security policies, essentially, it means that these spots inside of namespace 2 can actually do whatever they like. And they can also connect to the internet. So that would mean if namespace 1 is connecting, it will be knotted behind node 1 or node 2 or node 3. But if a namespace 2 is connecting, well, it will also be knotted behind node 1, 2, or 3. So for the firewall, there is totally no control at all to actually limit access. So what's happening in most cases is that the firewall is just allowing the Kubernetes cluster to reach the internet, which is not a very good idea. Just imagine that one of your pods get hacked or pods connect to pod control centers and so on and so forth. So we need to take a look at that. So one of the solutions that you can obtain with Calico open source is that you can actually use the concept of an IP pool. In short, remember, if you set up Kubernetes, you basically have to determine the Kubernetes pod network, which is typically something in the range of, just take like 10.000/16 or 10.00/8. That's essentially the network that you tell Kubernetes the pods will reside on. The moment you install Calico, you actually also have to tell Calico to use a range of IP addresses. Calico by default will take the network that you give to Kubernetes and make a smaller number of pools. We call that IP pools. The IP pool is just a concept in Kubernetes, in Calico, that says, okay, if you need to assign an IP address to a pod, just use one IP address out of the IP pool. Calico technically underneath will split up the IP pool in what is called IP blocks, which are smaller blocks, and an IP block is typically assigned to one or the other node. Long story short, it's just the way that Calico manage the IP addresses. Now, in Calico, you have the option to have IP and IP or VXLAN, but you also have the option to have no encapsulation, which is typically faster. It has less overhead. And the cool thing is that you can actually see the IP addresses. So let's resume or recap this. So in this scenario, we disabled no encapsulation. That means that we actually see the IP addresses on the network, which is, I think, even optional here. But the interesting thing is we disabled no outgoing, or we disabled outgoing address translation on the node. That means that if pod 1 connects to the internet, it will not be address translated on node 1 or node 2 or node 3. So that means that if the connection is set up from pod 1 to the firewall will actually see the IP address of the pod. Of course, the firewall needs to know the way back to the pod. So very often this implies that you have to set up BGP peering between your Kubernetes cluster and your firewall or router, but that's not that uncommon in data centers. Not to say very often the case. So to do this, the firewall needs to know the route back, but that's just a routing problem to solve. And at that point, the router might allow access, or the firewall might allow access based on the source IP of the pods. Doesn't resolve the problem that IP addresses are dynamic. So your firewall or your router doesn't know whether it's Nginx or a hacker. But to solve this, we might actually use a Calico concept called IP pools. You can create multiple IP pools, and you can actually explain to a deployment to use one or the other IP pool. So the moment you deploy, for example, your Nginx deployment, you can actually give it an annotation. When the annotation is basically specified to the pod or to the pool or the namespace for that matter, Calico will automatically put it in one or the other IP pool. So you might create an IP pool in Calico that you explicitly allow access to the internet. So if somebody puts the deployment in the right namespace, it's allowed access to the internet. If the deployment is sitting in another namespace, it's simply not allowed access to the internet. So that's a fairly easy way to do that. And this can be done using Calico open source, okay? Now, that's one way of doing that. Now, to make it even more flexible, and we introduced in Calico Enterprise recently the concept of an egress gateway. As you see in the previous example, it means that we have to disable encapsulation. We have to peer with the firewall or the router to make sure that these IP pools are actually sent to the right nodes and so on and so forth. So to make life easier, we introduced the concept of an egress gateway. Egress gateways are actually a series of pods that are running on your Kubernetes cluster. And these egress gateways are actually the only pods that can access the internet. So every pod or every deployment that you actually put will take an IP address, for example, from the default IP pool or from another IP pool, doesn't matter. And the moment that application wants to access the internet, instead of being routed and knotted by the nodes, is actually the traffic is actually tunneled from the application to the egress gateway. This is done automatically. This is how Calico does this. This is actually implemented and totally transparent if you want to use the feature. So Calico makes sure that the traffic leaving the pod is actually sent through the egress gateways. The egress gateways will, of course, on their turn, connect to the internet. And the cool thing is that you can actually create a specific IP pool. It's actually an IP pool which cannot be used by pods. And what the egress gateways will do is actually perform address translation to make sure that the traffic is routed to the gateway. So what a firewall is seeing is actually that IP pool of the egress gateways. So as long as traffic is not passing to the egress gateways, and that's under administrative control, traffic cannot reach the internet. So it's a little bit similar as the IP pool scenario, but in this case, you can create multiple egress gateways and you can actually hide an application behind a specific egress gateway. So you can have multiple egress gateways, and meaning that traffic originating from one or the other egress gateway can have different access mechanisms on the firewalls or not. As I mentioned, it's a feature of Calico Enterprise. It's pretty easy to use. Can be very handy in some scenarios. If you want more info, feel free to ping me. Last but not least, another way of controlling the access is through means of firewall integration. The one which I depicted here is actually an integration we have with FortiGate. So what happens here is that essentially once you deploy Calico Enterprise and you create rules that basically allow you to access the internet, well, the Tigera firewall controller, which is actually a Kubernetes controller, that will essentially populate FortiGate with the IP addresses of the nodes in this scenario. So it means that at Tigera Calico level, you define a very fine-grained policy. And at the firewall level, you actually say which nodes are actually hosting these pods. But that's in the case when you have IP and IP or VXLAN or outgoing NAT, essentially. But we also support pods. So the Tigera firewall controller can also populate the FortiGate, in this case, with the IP addresses of the pods. So you have a dynamic address group inside of FortiGate, which is updated with the IPs of the pods. And then FortiGate can, for example, use this address group to basically build policies on their behalf. So the trick here is actually that Tigera is actually building this address group based on labels inside of Calico. So I see one question: how does egress gateway talk to the outside world via a load balancer? The egress gateway can talk to the outside world through a router. It could be using a firewall that does address translation. That's one way to do it. Or by using BGP peering. The trick with the egress gateway is that essentially the destination IP address is still the destination IP address that you would always use. So it's source IP address of your application that will be hidden behind the egress IP pool. So the firewall or the gateway or something that's in front of your Kubernetes cluster just needs to make sure that you can route back the traffic to the IP pool. I see a question, firewall, do we write firewall rules? Refresh. I don't understand the question, but in the case of the firewall integration, we do automatically updates of the policies, the address group, so we cannot push a firewall rule, but we do the update of the address group. And on the, if the question is related to the egress, there is no integration with the firewall, so the firewall itself needs to have a rule allowing or denying communication coming from the egress pool. So yeah, egress gateway talking to a firewall, meaning there is no integration. So you need to create a rule inside of your firewall that allows the egress pool to access the internet. Okay, enough of slides. Let me try and use my UI here. Let me see. I hope you can see it. See. Okay. So before I forgot, I wrote down the URL. Where's the chat window? I don't see the chat. Okay, I'll put it in the chat window, this link. These are actually the examples that I'm using. There's just a few examples, but perhaps it's easy to copy paste them if you want to reproduce a few use cases. So on that link, what I actually do is to test out some of the scenarios. I'm actually creating my own namespace, my demo app. So that's pretty easy. So we can actually analyze this. And I'm using my own container that I'm using to test. You can use NetShoot or whatever, but just built my own container when I was young. So as you can see, it's just spinning up an image. I'll give it a label, allow internet egress true, which is useless at this point, but I will use this label to actually build my policies. I put it in the correct namespace, of course. And so if everything works well, I now have a shell inside of my demo app namespace with a specific label. So as I said before, a very good starting point is to actually say that your pods cannot connect to the internet. So to do this, let me see if I can enlarge this a little bit. I can actually apply a policy. And as I mentioned during the presentation, it says default deny all egress. So it's only blocking all the egress traffic. But something you should take care of if you do this is that your pods, if they need to connect to the internet, still need access to DNS. Whether this is a DNS outside, then you have to do it like this. If you're only using the Kubernetes, for example, for DNS, you could actually say that it can only connect to the Kubernetes. But just for the sake of this demo, this policy is actually blocking all traffic leaving from a pod and just allows DNS. What I just copy pasted just creates the YAML file. So I'd have it on disk. So I still need to apply this policy. And right now my pod is applied. As you can see, the pod was already up and running. So if I would do a curl to tigera.io, it would fail, of course. Just to prove my point, if I would do actually a dig, if it is installed to tigera.io, you see I actually get the IP address. You can do dig to my website, and you would actually see that DNS is working. But if I would connect to this website, it would fail. Okay, makes sense. I'm only allowing DNS traffic to get out. So in the next phase of the demo, what I wanted to do is say, okay, let's create a network policy, a Kubernetes network policy that just allows my pod to actually connect to the internet. So again, it's Kubernetes network policy. It will only allow traffic from pods with the allow internet egress. So that's fairly easy. If you copy paste this policy and you label your pod to allow internet egress, well, it will be able to access the internet for port 80 and 443. So created the YAML file. And if I apply this, as you can see, hopefully it's applied. So again, I'm still in this running pod. So if I would repeat this, you can actually see right now I'm able to reach Tigera or any other website. Okay, so it's immediately. That's how it works in Kubernetes. That's also how it works in Calico open source. If you're thinking, that's dangerous, well, in Calico Enterprise, we do support the option to have stage policies, which basically means that you can apply the policy, see what it would do, and then basically decide to put it in blocking mode or to effectively apply it. Now, this is something you can do with Kubernetes. These are Kubernetes policies. Let's do something more complicated. So in the next example, we're going to actually create a Calico network security policy, and I will be using the concept of a network set. Okay, as I mentioned, a network set is actually namespace bound, yeah, but I also can create a global network set. So these IP addresses on my website, so I know them probably already by heart. So I'm going to create the network set, and of course I need to apply this network set through, well, so right now this resource is created. We still have to bind it, of course, to a policy. So we're going to create a policy saying that every pod with this internet egress thingy set to true is denied access in this case to any destination which has the role equals API. And the role equals API was basically the label I specified in the network set. So this is a deny example. This you can only do with Calico open source and Calico Enterprise. So if I apply this, and if I'm lucky, it would mean that anything that is going to these IP addresses is basically blocked. Now, www.radarhack.com is one of these IP addresses. So if everything went right, you can actually see that access to this website is blocked. You might ask yourself your question, what if the IP address behind radarhack.com changes? Well, if it is not in the network set, it will actually be allowed. That's how we can solve this in one of the next examples. One downside of this approach is that, of course, it's namespace bound. Yeah? So that would mean if I would basically spin up a pod. Let me do this quickly, if I would spin up a pod, for example, in the default namespace, and it works out, you will actually see that if I would go to this website, it will work. So that's the pro and con, of course, of namespace. So to solve that problem, Calico also supports something which is called a global network set. So we can actually create a global network set here. So pretty easy. We'll create the objects. We're going to create a policy right now. Voila. So the policy right now says it's a global network policy. Yeah, that means that it's not namespace bound. And when we apply it, it's up and running. So if we do the same trick again, and we would spin up a pod in the default namespace, and if I would connect to the same website, it is blocked. So that's a cool way to essentially put in place one policy that blocks access to specific sites. Just imagine what you can do if you can populate the network set or a global network set automatically. In Calico Enterprise, the global network set can be controlled by somebody with way higher privileges and cannot be overridden by those who have access to only the namespace. So to more or less conclude this, let me clean up quickly the policies that I created. Well, they're gone. And let's do it a little bit more efficient. So I basically cleaned up everything except the DNS policy. And let's create, as you can see, a network policy. Again, it could be a global network policy. Sorry, it could be a global network policy. It could be using network sets. It could be using a global network set. I'm just taking one of the examples, but at the end, this one was quicker to copy paste. So it means that I'm creating a network policy, just allowing capture my pod. And it's actually mentioning that I can connect to anything which is in the domain that I own. So anything that basically ends with radarhack.com will be, in this case, allowed. Please note that DNS policies, or the ones that have the domain in here, are only Calico Enterprise and only allow the allow action, so you cannot drop on it. Long story short, let me apply this policy. And if everything goes well, it's applied. Now, I'm going to make a mistake on purpose. So if we want to test this, and I would say, let's do curl.radar.com, the policy that I created should allow it. And if my guesswork is okay, it fails. Not. If you do it more quickly, it fails. Why would it fail? For example, why is this? Actually, it's based on the fact that your container needs to do a DNS lookup. So this policy is only triggered, the access lists underneath all of this are only triggered when it actually sees a DNS request for radarhack.com. So if you wait for a while and your container basically loses its cache for DNS lookups, it will basically take it out of the cache and not do a DNS request. It would actually fail. So if I wait longer, it would have failed. And that's the way I actually prepared it. If nothing is in the cache, of course, your operating system, in this case, your container Linux, will basically do a DNS request. DNS request will be resolved. That's how Calico Enterprise picks up. So connecting to an IP address without a DNS lookup would miserably fail. This was more or less the end. The only thing I had left here, if you have a few minutes, is to quickly show you the integration. So let me see, can move away this, yeah. So what I have here is essentially a setup with an Nginx on OpenShift, as you can see. And in this lower bar, oops, something is wrong. No, this. So in this, I can close this. I don't need this anymore. So basically, I have here a console to the OpenShift one. And as you can see, when I have a bunch of pods which are labeled as environment DMZ, as you can see, there's only one pod running. If I go into OpenShift and I basically scale it to 2, you can actually see that OpenShift and Kubernetes, for that matter, because this will work exactly the same on Kubernetes, will spin up one more pod, of course. So on the other side, on this OpenShift cluster, there is, of course, Calico Enterprise for this demo. And on Calico Enterprise, we basically have a policy tier here, in a policy. So there's a FortiGate tier. The name is just something I made up. And essentially that policy here, if we take a look at it, basically selects all the pods with environment equals DMZ, same, and with a lack of inspiration, I actually said that it connects to anywhere, to everywhere. So it's a pretty open Calico policy that just allows my pods to connect to anywhere. So you can see it's a global policy. So everything which matches this label will be allowed to talk to everything. Now, the cool thing is here, everything which is actually captured by this policy, so you can actually see in the policies, let's see, toggle stats, yeah, that just show all. You can actually see the number of endpoints here that are actually being captured by Calico. So if my assumption is right, and I would increase the count here, we would actually see after a few seconds, like it was already there, and now it's gone. Let me see. Okay. It will come back, but at the end that it will match 3 endpoints. So what Tigera is actually doing on the, it's back there, background is that it basically knows which endpoints are actually captured by this policy. And we configure Tigera to actually communicate securely to the FortiGate environment and actually announce these endpoints to FortiGate. So if we take a look at the FortiGate and we log in, to the FortiGate, we'll actually see that. Save, and we go to addresses. Yeah, there is a FortiGate tier here. That's the name I specified, and test is the name of this policy. And that there are 3 Kubernetes nodes listed. That's because I have a 3-node Kubernetes cluster, and my 3 Nginx pods are actually on 3 different nodes. So let's put a proof in the pudding. So if I would decrease the number of pods back to 1, we'll see that Kubernetes will be terminating the pods, and we're back to 1 pod right now. If I would go to FortiGate and I'll refresh the page, we will actually see that the FortiGate address group is actually back to 1 node. In this case, it's using address translation, so it's a default install. So that's why we see the IP addresses of the nodes. But as I mentioned, you can use the pod IP addresses, but that means that, of course, the FortiGate needs to be able to route back to the pod network, which is pretty obvious. This address group, I can actually go and use into security policies inside of FortiGate. So if I want, for example, these pods to be only allowing to connect to Google, I can actually configure that inside of FortiGate. This is more or less what I had to say. Sorry, I ran out a little bit in time, but I hope it was interesting.
We've got one final question there, Philippe.
Yeah, see, if anyways I have to make firewall change to allow egress gateway pool, why can't I just have firewall rules instead of additional egress gateways? The purpose and the advantages of using egress gateways is, first of all, that you can hide multiple namespaces or multiple pods behind one set of egress gateways. That's one thing. Of course, you can use the line is subtle between IP pools and IP gateways or egress gateways, but the advantage is that you can hide it behind one set of egress gateways if you want to, and that you can control who is sitting behind these egress gateways or not. You only have to allow once the egress gateway IP pool into the firewall or the router, but it allows you to do it like this. So most of these scenarios, egress gateways or the one we have like the firewall integration here, the main idea is that you have access lists on both levels. It's very hard, for example, to control everything, and which is very often a request from our customers that they can control access on the firewalls in front of Kubernetes. And due to the fact that Kubernetes is quite often doing address translation, it means that at the firewall level, you have very little visibility except all the cluster IP nodes. So as well as the one I just showed you for FortiGate or the solution with the egress gateways allows you to at least fine-tune the rules on the, let's say, first level of firewalls or NAT devices. But a good design would always imply that you have very granular rules on top of Calico Enterprise and have like more coarse-grained rules on the first layer of firewalls. I hope this answered the question more or less. As I mentioned, feel free to reach out if you have any questions. I hope it was interesting and that we learned something altogether today. check out the events, please, that my colleagues are hosting. And if you want to try out I've lost my slides, but anyway, if you want to try out Calico Enterprise, go to Calico Enterprise trial. So you can essentially, here it is. You can actually try it out for free. Go to tigera.io.trial and you can sign up and you can play around with the full, yeah, I gave it, with the enterprise product. So see the policy tiering, the staging, troubleshooting tools, flow controls, and stuff like this. And of course, logging information that could fairly be a big help when you have to troubleshoot access policies. Thanks. Hope to see you soon. I will be back, I think, in EMEA timeframe in 2 weeks from now with the topic of Calico in EKS. Thank you. Speak to you later. Cheers.